Hello everyone, and to our lecturer Encik Burhanuddin. Okay, my name is Fiknis. I'm from class DJL 4A. My metric number is 10 DJL 21F 1005, and following with my group members, Kiti Vasan, Muhammad Muzakir, Nur Hidayah, Saiful Daniel, Muhammad Farzan Hafizi, and then Raja Muhammad Faiq. Okay, the theory of internal combustion engine is four-stroke engines have four valves so that piston can go through four events to complete one four-stroke cycle. A piston motion, either upward or downward, is defined as an event. After these four events, the cycle is complete and ready to restart. The intake and exhaust valve regulate the air or fuel mixture that enters and exits the cylinders. During the four-stroke cycle, the intake and exhaust camshaft open and close the intake and exhaust at precise time. Okay, this is the picture of for four-stroke cycle. The first one is intake stroke, and then the second one is compression stroke, and then the third one is power stroke, and then the fourth one is exhaust stroke.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noida Binti Rosli and my metric number is 10DJL21F1003. So this is the intake stroke. Piston descends the cylinder before from top dead center TDC to bottom dead center BDC. Second, intake valve is open and the exhaust valve is shut. Third, downward motion of the piston creates a vacuum which draws the air or fuel mixture into the engine through the open intake valve. Compression stroke. First, piston move up the cylinder bore from BDC to TDC. Second, intake and exhaust valve are both closed. Third, upward motion of the piston compress the air or fuel mixture in the combustion chamber. Power stroke. First, spark plug fire and ignites the compressed air or fuel mixture just before the end of the compression. This ignition or combustion forces the piston down the cylinder bore and rotates the crankshaft, propelling the vehicle forward. Second, piston move down the cylinder bore from TDC to BDC. And the last one is intake and exhaust valve are both closed.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Muzakir bin Kanwiz Abba. My metric number is 10J21F1002. Okay, today I will explain about four-stroke cycle. Okay, one of four-stroke cycle is exhaust stroke. Okay, how exhaust stroke work? Piston move up the cylinder bore from BDC to TDC. The momentum created by the power stroke keep the crankshaft moving, and the other three strokes going in sequence. Okay, intake valve is closed and the exhaust valve is open. Okay, final stroke push the spent gas and exhaust out of the cylinder. The cycle is now complete and the piston is ready to begin the intake stroke. Okay, the next is valve timing diagram. Okay, what is a valve timing diagram? Okay, valve timing diagram is a graphical representation of the opening and closing of the intake and exhaust valve of the engine. The opening and closing of the valve of the engine depend upon the movement of piston from TDC to BDC. This relation between piston and valve is controlled by setting a graphical representation between these two, which is known as valve timing diagram. Okay, the valve timing diagram comprise of 316 degree figure which represent the movement of the piston from TDC to BDC. In all the stroke of the engine cycle, which is measured in degree, and the opening and closing of the valve is controlled according to this degree.
Okay, my name is Haji Muhammad Faiq bin Raja Azhar. Today I want to present about overlap in ICE. Okay. First point, As the engine cycle, there is a period when both the intake and exhaust valves open at the same time. This valve timing is known as overlap. The main reason to utilize precision lapping service include controllable thickness identity, surface finish, part uniformly, flatness, camber reduction, camber reduction, parallelism, and preparation for polish. Okay, now I want to explain about TDC. The position of a piston in which the head is farthest from the crankshaft is known as top deck center. The ignition system measurement and firing timing calculation for all the piston in reciprocating engine are made from the TDC of a piston. The spark plug may be discharged precisely at the right time for the most efficiency burn when the TDC is known and the angle encoder pinpoints the precise crankshaft angle. Knowing when TDC is reached can also aid in the investigation of engine energy conversion process. Okay, now I want to explain about BDC. The location of an engine piston closest to the crankshaft, this is called bottom dead center. This is the lowest the piston can go in a vertical engine. The piston begins to move upward when it's reached bottom dead center. A compression stroke occurs when the piston rises from bottom dead center. The fuel mixture is driven into the cylinder by system pressure as soon as the intake valve open, and the piston descends to bottom dead center. Okay. Now I want to pass next slide to my group member.
Assalamualaikum warahmatullahi wabarakatuh. My name is Saifuddin Jabir Shaharuddin. My metric number is 10DJL21F1004. As you can see here, first result is given by our lecturer and result 2 is our group doing experiment. We have successfully doing the experiment by plotting all the point. Result 1, high speed engine. High speed is usually 100 rpm and above. Angle degree TDC, inlet valve open, is bigger. Result 2, low speed engine. Why slow speed diesel engine have 100 to 120 rpm? Angle degree TDC, inlet valve open is smallest.
My name is Muhammad Farhan Hafizi bin Jumain. My metric number is 10DJL21F1006. I would like to continue this presentation. 4-stroke advantage. First, 4-stroke engine give higher efficiency. Number 2, it creates less pollution. Number 3, less wear and tear due to good lubrication system. Number 4, it is quieter in operation. Number 5, it is run cleaner due to not extra oil added in fuel. Number 6, they give high RPM at low power. Disadvantage of 4-stroke. First, these engines are more complicated due to valve mechanism and lubricant system. These are costly compared to 2-stroke engine. And lastly, 4-stroke engine give less power. Comparison between a 2-stroke engine and a 4-stroke engine. A 4-stroke engine weighs 15% heavier than a 2-stroke engine. A 4-stroke engine is more efficient than a 2-stroke engine because fuel is consumed on every 4-stroke. A 2-stroke engine creates more torque at a higher RPM, while a 4-stroke engine creates a higher torque at a lower RPM. A 4-stroke engine is quieter than a 2-stroke engine. 2-stroke engine tend to wear out fast because they are designed to run a higher RPM. Two-stroke engines are easy to fix because of their simple construction. Four-stroke engines have complex design with more parts, making them more expensive and repair cost more. Two-stroke engines are typically found in smaller applications such as chainsaw, boat motor, and dirt bike. Four-stroke engines are found in go-kart, lawnmower, and combustion engine in your car.
Hi everyone, my name is Kirtivasan. I'm from class DJL 4A and my metric number is 10 DJL 21F1001, and today I'm going to present about internal combustion engine. Internal combustion engine are a fascinating piece of machinery that have changed dramatically over the years to produce astonishing amount of power. Combined with the latest technology of electric motors, car will continue to improve dramatically. Some electric car fanatics claim that the days of the combustion engine are numbered, but with much history, we sure hope that won't be for a while chill. As a conclusion, the internal combustion engine has been critical in shaping the modern world for over a century. It has revolutionized transportation and power industries. Despite its numerous contributions, the internal combustion engine is lacking of growing challenges in terms of sustainability and environmental corners. While the internal combustion engine has provided mobility and economic growth, it also has a significant source of air pollution and greenhouse gas emission. The combustion of fossil fuel like petrol and diesel emits carbon dioxide, nitrogen oxide, and particulate matter, which contributes to climate change and poses health risk. To address this issue, there is growing shift towards alternative technologies like electric vehicle and hybrid system, which provide cleaner and more sustainable solution. To reduce reliance on fossil fuel and harmful emission, government, industries, and researchers are investigating in the development of electric and hydrogen powered vehicles. In conclusion, while internal combustion engines have been a driving force behind progress and mobility, their environmental impact, necessity, and shift towards more sustainable alternatives continuously advanced and electric and hybrid technologies as well as stricter emission regulation aim to multiply the negative effect of traditional combustion engine and shape a cleaner and greener transportation for future. Thank you.